Good afternoon, everyone. My name is Rukku Raju. Welcome to KP classes. So, in today's section, we'll be discussing about hydrogeology formulas for the Combined Geoscientist Examination 2024. So, this is a UPSC examination for getting a job as a geologist or as a hydrogeologist in Geological Survey of India or Central Groundwater Board. So, I hope my audio is clear for everyone. So, could you please confirm whether the audio is clear? Okay. So, anyway, let's move on to the equation part. So, when it comes to the hydrogeology equation, why do we need equations for UPSC Geoscientist Examination, Combined Geoscientist Examination? What is the purpose of understanding the equation? Because it's not like a GATE or a NET examination, there is very few numerical questions will be asked, right? So, what is the importance of having having something related to hydrogen equations here in the UPSC? So, the importance is that, see, there are questions like these will be asking. They will give you a set of details, and among the following, which is the correct storage coefficient of aquifer. So, if you don't know the basic equation of storage coefficient, storativity, if you don't know the equation, you will not be able to answer these kind of questions. So, this is a very common question in UPSC paper. Every year there will be 2-3 questions from these sections where they'll be asking a particular equation. So, how will you understand what do we have to do to solve these kind of questions? You should be very thorough with the equations. So, they either usually they ask questions from hydrogeology formulas, which is not always. Sometimes they will be asking you questions related to structural geology equations or engineering geology equations. They can ask any part, but this is a very common type of question. This I have a set of examples. See, this is another question. This is from Darcy's law. So anyway, here we'll be going through each and every equations related to hydrogeology. So there will be a continuous series like this till the GSA examination from KP classes. We will be conducting live sections so that you will be able to understand the importance of questions, the different questions in the UPSC Geoscientist examination, and along with that will give you the required materials for revision. So here in this section, this is for hydrogeology formula. In the next section, let's solve, will give you some solutions related to these kind of questions and how to get into the derivation. Sometimes they will not give you the direct equation. Sometimes they will give you the direct equation also. So, this is not a direct equation for Darcy's law, or this one is also not the direct equation of storage coefficient. So, if you don't know 2-3 terminologies, like what is the basic equation? In the basic equation, we don't use the bulk modulus, we use the aquifer compressibility and water compressibility terminology. So, if you don't know the relationship between compressibility and bulk modulus, you will not be able to get the answer from this section. So, anyway, we will be discussing the equations over here for today, and from the next sections we will be solving questions related to this particular pattern. So, let us begin with hydrogeology equation. So, which one is the most important part in hydrogeology? That is porosity itself. So, porosity equation is a very basic one. It's very, everybody knows that. It's the volume of void to the total volume. That's the equation for porosity. Porosity is equal to volume of void divided by total volume into 100. This is one equation for porosity. There are multiple equations. Porosity can be related with bulk density and particle density. Porosity is equal to Porosity is equal to bulk density by particle density 1 minus bulk density by particle density. This will also give you the term porosity. This equation is the gravimetric method of calculating the porosity term. Then we'll see the rest of the equation when we go further. So after porosity, there is a terminology called as void ratio. Void ratio is notated by the letter E. Void ratio is the volume of void to the total volume of the soil sample. Volume of the soil sample. This ratio is called as void ratio. There is a relationship between void ratio and porosity. Void ratio is equal to porosity divided by 1 minus porosity. This is the relationship between void ratio and porosity. Next major part is the Darcy's law section. What is Darcy's law? What is Darcy's law states? Darcy's law states that the discharge Q or the flow rate Q is directly proportional to the cross-sectional area, the change in the hydraulic head, and it is inversely proportional to the distance between the permeameters, and there is a proportionality constant, that is hydraulic conductivity or coefficient of permeability, that is K. So Q, which is the discharge, is equal to Ka dH by dl. Ka dH by dl. So we have to use this equation for solving this particular question. See, consider the following regarding Darcy's law. L is the length of the column, K is the hydraulic conductivity, H1 minus H2 is the difference in the hydraulic head. Which one of the following is the correct rate of flow or flux velocity of groundwater V through which a column of saturated sand in accordance with the Darcy's law? This is the question. So, they are asking the flux velocity of groundwater. Flux velocity of groundwater is the next term, that is the Darcian velocity, which is also called as Darcian velocity or specific discharge. Specific discharge. Darcian velocity or specific discharge is notated by the letter small q, which is the discharge divided by the cross-sectional area A, or Q by A is equal to hydraulic conductivity into dH by dl. dH by dl. Okay, is this, I hope it's clear for you. Okay, so Darcian velocity or specific discharge, Darcy's law, porosity and void ratio related equations. Now there is another terminology called as the average pore water velocity. Pore water velocity, which is notated by the letter V dash. Pore water velocity V dash is equal to porosity into Darcian velocity Q. This V dash defines the velocity of water through the pore space, through each individual pore space. What is the velocity of groundwater? That is notated by the letter porosity into Darcian velocity. Darcian velocity defines the speed if we consider the entire aquifer system as a single pipe. There we are not considering the minute lakhs of pore spaces that exist, and the groundwater actually passes through those pore spaces, right? So over here we are not considering that. We consider the entire aquifer as a single pipe, and depending upon the cross section, the distance between the either ends and the variation in the hydraulic head, whatever is the velocity of flow, that is the term Darcian velocity. whereas pore water velocity defines the velocity of water passing through the pore spaces. Passing through the pore spaces. Now the next equation is defining the energy of groundwater flow. So anything to move, there should be whenever there is a temperature heat flow happen. Heat flow only takes place when there is a variation in the temperature between two ends, right? Or when there is a current flow happen, and that's because of the variation in the voltage. So that difference is which causes the movement, which causes the flow. We call that as a potential difference. So for the movement of groundwater, it also required some variation in the energy. So that amount, or that the energy that actually causes the movement of water, movement of groundwater, is defined by the term hydraulic head. Hydraulic head, which is notated by the letter H. Hydraulic head H is actually equal to the pore water pressure P plus the elevation head Z, elevation head Z. So the actually pore water pressure depends upon the water column height. Elevation head defined by the height of the well, or the point which we consider from the datum. So that if I consider PW as the water column height plus elevation at that point is termed as Z, this defines the hydraulic head. So hydraulic head depends upon both pore water pressure and the elevation at which the well is situated. For example, if this is the surface and there is one well at this particular location and there is another well over here at different locations. So this is well number 1, this is well number 2, and there is this is the datum plane over here. Datum. So this is the elevation of first well and this is the elevation of second well. Now water column height of first one is this much. So this is the P1, the water column height, whereas in second one this is the water column height. So altogether, the when it comes to the hydraulic head of well number 1, hydraulic head of well number 1 is actually this much, because Z1 plus P1 will be the hydraulic head at well number 1, whereas hydraulic head at well number 2 it will be only this much. So from this image we know that well number 1 hydraulic head is much greater than the hydraulic head of well number 2. So there is a difference in the hydraulic head from well number 1 and well number 2. So obviously groundwater is actually flowing from this location to this location. From higher head to lower head will be the flow of groundwater takes place. So always remember, hydraulic head depends upon both the summation of pore water, the water height in the well and the elevation. For water, the height of water column over here and elevation. Okay, it is the sum that defines the hydraulic head. Here you can see in either this well are almost situated at the same elevation. So it's not the elevation that defines not only the water column, it's the sum of both defines the hydraulic head, or from where to where the flow happens. I hope this is clear, and we derived this equation from the Bernoulli's equation. So Bernoulli's equation, so I hope this much is clear. If you have any doubt in between, you can mention that in the comment section. Equation number 6 is of hydraulics head. Now equation number 7. Bernoulli's equation. Bernoulli's equation state that the total energy required for the flow of water, the total energy required for the flow of water, or the total mechanical energy E of a particular water column. E is equal to, it is the summation of the potential energy at that particular location, which is notated by mgh, height of water column. Here h defines the height of water column. This is not the hydraulic head. Write it as capital letter H. Okay, this value, no, this is Z. Elevation. Elevation is what defines the potential energy. Mass of water column, acceleration due to gravity, and the elevation at which the water column exists. mgz plus kinetic energy mv square, half mv square, velocity of water flow, mass of water column. This is the kinetic energy terminology. And the third one is the pore water pressure. Pore water pressure is the pressure exerted by the water column. Pore water pressure P. Pore water pressure P is defined by the amount of the thickness of water column over here. So that is actually rho GH is what is the pore water pressure terminology, rho GH. Now, if we okay, yeah, this is the equation. So I'll write over here. Pore water pressure F. Okay. So this is the Bernoulli's equation. Bernoulli's equation. Next is the terminologies associated with permeability, that is intrinsic permeability. Intrinsic permeability. Intrinsic permeability is notated by the letter small letter k. Small letter k. So intrinsic permeability is simply describes the is ability to transmit water of a geological unit. Intrinsic permeability defines the measure of the ability to transmit water in a geological unit is defined by intrinsic permeability. So intrinsic permeability is equal to hydraulic conductivity K, rho G. Rho is the density of water, G is the acceleration due to gravity, divided by the dynamic viscosity mu. Divided by the dynamic viscosity mu. Hydraulic conductivity K, density of water rho, acceleration due to gravity G, divided by dynamic viscosity mu. So intrinsic permeability is only the factor of the medium present. Okay, yeah. Intrinsic permeability equation is equal to K is equal to CD square. Then this is intrinsic permeability. The equation that I wrote was coefficient of permeability K, or hydraulic conductivity K is equal to intrinsic permeability small k into rho G divided by mu. Okay, sorry. So here the intrinsic permeability is only the factor of the medium. Here C is the shape factor, D is the diameter of the pore space, diameter of the pore space. Hello, hi guys, I hope the lecture is clear for you. Okay, good evening. So over here, intrinsic permeability small k defined by the shape factor C, which is a constant, and D is the diameter of the pore space. So it is pretty clear that intrinsic permeability is the factor of the medium. It only function of the medium. It only defines the property of the medium. What is the ability of the medium or the rock unit to transmit water. That ability of the medium is defined by intrinsic permeability. Whereas when it comes to the hydraulic conductivity, coefficient of permeability, it depends upon the intrinsic permeability of the medium, density of water, acceleration due to gravity, and dynamic viscosity of the fluid or the water. So, coefficient of permeability depends upon both the medium in which the fluid passes through and the property of the fluid also. So, both medium and the fluid property matters to define the hydraulic conductivity K. Whereas for intrinsic permeability, it only defines the property of or the function of the medium. Whatever is the pore space diameter, that is what defines the intrinsic permeability terminology. Whereas both the diameter of the pore space and the dynamic viscosity of the fluid, density of fluid, all these matters to define the coefficient of permeability or hydraulic conductivity terminologies. Okay. Next equation for transmissivity. Transmissivity T is equal to hydraulic conductivity into the saturated thickness of the medium B. Saturated thickness of medium B. That's the equation for transmissivity. Hydraulic conductivity into B. The B is the saturated thickness of the aquifer. Okay. Now the next equation is the equation related to the groundwater flow. Groundwater flow equation for a steady state condition. Groundwater flow equation for a steady state situation. The groundwater flow equation for steady state means the hydraulic head will not change with time. That's what is defined by the steady state condition. Hydraulic head in the system will never change with time. So isotropic medium exists where there is no difference in the properties, hydraulic properties along with the direction. So, the equation for groundwater flow term will be del square H by del x square plus del square H by del y square plus del square H divided by del z square equal to 0. Same way, if I write down the groundwater flow equation, so this is steady state condition for isotropic medium. Isotropic medium, then this equation, groundwater flow equation for steady state in anisotropic medium. Anisotropic medium is equal to del by del x of hydraulic conductivity Kx del h by del x plus del by del y of Ky del h by del y plus del by del z of Kz del h by del y is equal to 0. Then next equation is for horizontal hydraulic conductivity for horizontal hydraulic conductivity KH is equal to K1 B1 plus K2 B2 plus Kn Bn divided by B1 plus B2 plus Bn. Okay, or summation of K1 B1 the hydraulic conductivity and the thickness of the layer divided by summation of the thickness of the whole layer. Then same way for vertical hydraulic conductivity Kv is equal to B1 plus B2 plus etc. to Bn divided by B1 by K1 plus B2 by K2 x plus B3 by K3. Sorry, Bn by K3. Write the equation down. So this is the groundwater flow equation for steady state in an isotropic medium. This is the groundwater flow equation for steady state in anisotropic medium. This is the horizontal hydraulic conductivity for terrain where there is multiple horizontal beds are there, and altogether there is a horizontal flow of water takes place. So this is the equation that you have to use. This is the vertical hydraulic conductivity equation. Okay. Now next terminology is the how to calculate the storativity or storage coefficient. Storativity or storage coefficient is actually notated by the letter S. This is equal to storativity or storage coefficient. S is equal to the thickness B into specific storage SS, thickness B into specific storage SS. This is for a confined aquifer, where for a unconfined aquifer the equation can be B into Sy, whereas Sy is the specific yield. So what is this? SS, yeah, specific storage. SS is equal to, this is a parameter for a confined aquifer only, where the amount of water, the volume of water that has been, which a unit volume of the confined aquifer releases from a storage because of the expansion and compression of the aquifer. So this expansion of aquifer or compression of water, compression of aquifer or expansion of water is the cause of release of water from a confined aquifer. So by using those two terminologies, Specific storage is equal to density of the fluid into acceleration due to gravity multiplied by the aquifer compressibility beta plus aquifer compressibility beta, sorry, aquifer compressibility is notated by the letter alpha, alpha plus the effective porosity phi into water compressibility beta, fluid compressibility beta. So this thing we can also write it as SS into specific weight. Density into acceleration due to gravity is the specific weight. Specific weight is notated by the letter gamma. Gamma into then alpha is the aquifer compressibility. There is a relationship between compressibility and bulk modulus of elasticity. Inverse of bulk modulus of elasticity is compressibility. So I can rewrite it as bulk modulus of elasticity of aquifer particle 1 by bulk modulus of elasticity of aquifer particle plus porosity into 1 by bulk modulus of water. Now the equation for specific yield. Specific yield SY is equal to the volume of water drained because of gravity to the total volume of the sample, to the total volume of the sample. So we can rewrite it as volume of water drained divided by the total volume. This ratio is called as specific yield. Then or not always this 100% of water will be drained because of the surface tension properties. There will be some amount of water retained back in the soil sample in the pore space, which is defined by specific retention. So specific retention is notated by the letter SR, which is equal to volume of water retained divided by the total volume of water. Volume of water retained divided by, so this retaining of water is happening against the gravity. Okay, against the gravity, maybe because of surface tension. Now over here, if I add specific yield plus specific retention, that will be equal to porosity. Okay, specific yield plus specific retention will be equal to porosity. I hope that is clear. Then next equation is related to the storage, the change in storage or the water balance equation. Water balance equation is also called as water budget equation, hydrological budget equation, hydrological budget equation is the most common term. So which defines the change in storage in a water unit, which is equal to change in storage is actually, so if I am considering a lake, so from in the January we'll consider there how much is the volume of water present in the particular water source. It can be whatever you consider. It can be an aquifer, it can be a lake, any water related body that you can consider. So now after a year, like if the time span you use is an year, after a year you again look into the storage. So the difference in the storage that is defined by the delta S, yeah, change in storage, depends upon the difference in the term inflow minus outflow. Inflow means the amount of water that has been added into the system. whatever system we consider, if it is a lake, the system water addition can be because of precipitation, normal precipitation. If there is a surface water flow into the lake, that can also add water. If there is a groundwater input or an anthropological input of water, all these can add as an inflow into the lake. Whereas outflow will be the amount of water taken from the system. So if it can be evaporation, it can be transpiration, groundwater outflow can happen, or there is a surface outflow happening from the lake, or anthropological outflow, like we are pumping out water from the lake for a household purpose or for industrial purpose. So there we are removing the water, that is the anthropological outflow term. All these will be added to the outflow. So the difference between inflow and outflow defines the term change in storage, which if the change in storage is equal to 0, that means inflow is equal to outflow, then we say that the system is under a steady flow condition, steady state. There is no change in the water storage condition has happened. Or if there is more outflow happen than inflow, then the system has a negative storage variation. If there is more inflow than outflow, then there is a positive increase in the storage has happened to the system. So this is the water budget equation. Then next one is the terminologies associated with the volume of water that has been stored because of the stored in the surface depressions because of precipitation. For example, the volume of water stored in surface depressions, water stored in surface depressions, V is equal to SD. SD defines the maximum storage capacity. Maximum storage capacity of the depression, SD multiplied by 1 minus E raised to minus K PE. Whereas K is a constant, PE is the volume of precipitation that has happened. PE defines the volume of precipitation that has happened. Okay, so this is the equation which defines the volume of water stored in the surface depressions. Then the equation for water hardness. Hardness of water. Water hardness is defined by 2.5 and the amount of calcium content in the water plus 4.1 into the amount of magnesium content in the water. This is what defines the hardness of water, and we define it in mg per liter. That's the unit, mg per liter. Now when it comes to the next term, that is the sodium adsorption ratio. SAR, sodium adsorption ratio, SAR, is the measure of the sodic content of the soil, measure of the sodium content in the soil, which is equal to the amount of Na plus divided by Ca2 plus Mg2 plus divided by amount divided by 2 root over. Okay. Concentration of sodium, concentration of sodium divided by root over concentration of calcium plus concentration of magnesium divided by 2. Then the last equation is the Ghyben-Herzberg relationship. Ghyben-Herzberg relationship. Ghyben-Herzberg relationship is for defining the depth of salt water intrusion that has happened along the coastline. So because of the over exploitation of groundwater along the coastline, the intrusion of salt water happens into the aquifer which is situated near to the coastline. So we will be calculating the depth to which the intrusion takes place. So that depth to which intrusion takes place, or the from the datum plane uh, or from the mean sea level to what depth the saltwater intrusion has been happened, is calculated by, notated by the letter Z. Z defines the mean sea level to what depth the water intrusion, the saltwater and freshwater interface exists. That is notated by the letter Z, which is equal to 40 times HF, where HF is the height of water table from the mean sea level. The height of water table from mean sea level is the HF. So this 40 terminology is actually calculated by putting the normalized data of, you can rewrite it as density of water divided by density of salt water minus density of fresh water into HF. We can rewrite the term in this way: density of fresh water divided by density of saline water minus density of fresh water into height of water column from the mean sea level. So this if we put the average, the density of fresh water has taken as 1000, then the saline water density will be taking the average saline water density, that is 1025 kilogram per meter cube. So if I put all those data over here, it will be approximately equal to 40. So you can either use this equation or this one. So these are the important equations related to hydrogeology. Uh, they can ask both numerical questions, which are very few in number, and along with that they will also ask questions related to equations. So these are the major equations that you have to keep in mind to solve questions like these. Okay, so in the next section we'll be defining the equations, the questions, we'll be solving the questions which is having a pattern of these, and along with that we'll also solve the numerical questions. So for the videos related to geology, I request you to subscribe to our KP classes YouTube channel, or you can follow us in our Facebook and Instagram channels too, so that there we'll be sharing quizzes related to geology or important news related to geology. The study related free materials will be available. Important images will be uploaded. So you can follow us if you are a GATE NET or UPSC as Geoscientist Examination aspirant. You can follow us. If you are interested in getting our course, you can call us in this particular number. We'll give you the details regarding the batches which has already started for the 2025 GATE examination, June NET examination, 2025 UPSC paper. So for all the competitive exams, we'll be giving you separate lectures, separate classes, study materials, mock tests, test series, etc. So if you have any doubt related to geology lectures, or how do we teach, or if you want a demo class, there is a link given in the description box down below. You can fill the form. We'll be giving you a demo lecture, or you simply call in this number, or you can WhatsApp in this particular number. We'll send you the details. So stay tuned for the next live section regarding the UPSC exam, which is going to happen in the February 2nd, 3rd weeks. Thank you so much. We'll meet in the next video. Bye.